simplify the following square roots. Notice how these square roots contain variables. We simplify square roots with variables just like we simplify other square roots, except when finding the square root of an expression that contains variables raised to a power, we need to consider that the square root of x squared equals the absolute value of x, not just x. And this is because this is the principal square root, and this result must be positive. For example, if we consider when x is equal to, let's say, -5, we would have the square root of the square of -5 equals the absolute value of -5. Simplifying, we get the square root of 25 equals 5, which is true because this is the principal square root. Notice how without the absolute value on the right side, we would have the square root of 25 equals -5, which is not true because this is the principal square root. So in general, when simplifying a square root, if a variable outside the square root has an odd exponent, an absolute value is needed. Let's look at one more example. Here we have the square root of 16x to the fourth y to the sixth, which simplifies to 4x squared y to the third, and because the exponent on y is odd, we need an absolute value. The exponent on x is even, and therefore it does not require an absolute value. However, some sources do include both variables in the absolute value, which does not affect the simplified result. And again, the reason we need an absolute value around y to the third is because if y is negative, y to the sixth would be positive, but y to the third would be negative, and it has to be positive. Let's look at our examples. Here we have the square root of 36x to the sixth. 36 is a perfect square because it's equal to 6 times 6. So let's write this as the square root of 6 times 6. X to the sixth is also a perfect square because it's equal to x to the third times x to the third. So here's a perfect square factor, and here's a perfect square factor. Let's write this as the square root of 6 squared times x to the third squared, which we can write as the square root of 6 squared times the square root of x to the third squared. The square root of 6 squared simplifies to 1 factor of 6. The square root of x to the third squared simplifies to 1 factor of x to the third. But because we have an odd exponent on the variable x, this requires an absolute value. This will assure the result is always positive. Number 2, 54 is not a perfect square. Let's determine the prime factorization of 54. 54 is equal to 6 times 9. 6 equals 2 times 3. 9 equals 3 times 3. So we have the square root of 2 times 3 times 3 times 3. X to the fourth is a perfect square because it's equal to x squared times x squared. Y to the seventh is not a perfect square, but it does contain a perfect square factor because y to the seventh can be written as y to the third times y to the third. So this product gives us the perfect square factor of y to the sixth, and we still have 1 factor of y. Now let's circle the perfect square factors, which should be 3 times 3, x to the second times x to the second, as well as y to the third times y to the third. Let's go ahead and write this again, changing the order of multiplication and using exponents. Let's write this as 3 squared times x to the second squared times y to the third squared times 2 times 3 times y. And now we'll write this as a product of 1, 2, 3, 4 different square roots. This is equal to the square root of 3 squared times the square root of x to the second squared times the square root of y to the third squared times the square root of 2 times 3 times y. Simplifying, here we get 1 factor of 3, here we get 1 factor of x squared, here we get 1 factor of y cubed, and then we still have times the square root of 6y. The exponent on y is odd, and therefore this requires an absolute value. After doing this a while, we can probably go from this step here to the simplified square root, but for these 3 examples, I do want to show detailed steps. For the last example, we'll begin by determining the prime factorization of 192, 192 is equal to 2 times 96. 96 is equal to 2 times 48. 48 is equal to 6 times 8. 6 equals 2 times 3. 8 equals 2 times 4. 4 equals 2 times 2. So we have 1, 2, 3, 4, 5, 6 factors of 2 and a factor of 3. X squared is a perfect square because it's equal to x times x. Y the third does contain a perfect square factor. Y cubed does contain a perfect square factor. It's equal to y times y times y. And z the 12th is a perfect square factor because it's equal to z to the 6th times z to the 6th. Now we'll circle the perfect square factors. For this example, let's skip the extra steps and go straight to the simplified square root. Everything we have circled represents a perfect square factor and will simplify to one of the two equal factors. So the square root of 2 times 2 simplifies to one factor of 2 here, here, and here. The square root of x times x simplifies to one factor of x. The square root of y times y simplifies to one factor of y. And the square root of z to the 6th times z to the 6th simplifies to one factor of z to the 6th. And we're left with the square root of 3 times y, or 3y. Simplifying one last time, 2 times 2 times 2 is 8, and therefore this simplifies to 8 x, y, z to the 6th times the square root of 3y. But notice how the exponent on x and y are both 1, which is odd, and therefore x and y require an absolute value. So we have 8 times the absolute value of xy times z to the 6th times the square root of 3y.